Okay, let's wrap up Chapter 8 by examining Section 8.6, Identifying Special Quadrilaterals. This is the section where we put everything we've learned about quadrilaterals all together. And so, if I give you a quadrilateral with certain properties, you should be able to conclude what type of quadrilateral it is, or at least give a few options for what type of quadrilateral it is. So let's start. The first problem, I just want to review everything. Make a diagram that classifies different types of quadrilaterals. So I'm just going to make a big box. We talked about this a little bit separately throughout each day. And this box represents all of the types of quadrilaterals I could possibly have. But then within the family of quadrilaterals, we get other special types. So, one special type of quadrilateral we spent a good amount of time on, which is why I'm making this so big, is the parallelogram. Within the family parallelogram, we talked about rhombuses, and we talked about rectangles. And then we said the intersection of rhombus and rectangle, so the objects that are both rhombuses and rectangles, are squares. Okay, then we talked about, I'll use blue, then we talked about trapezoids. And the only kind of subset we had here was a special type of trapezoid, the isosceles trapezoid. And finally, we talked about kites. And there's no subset to the family kites. A kite is a kite. There's no special kind of kite. Okay, so this is the world we're working in. And as I explained earlier, you need to be able to kind of translate in both directions. If I give you one of these figures, you should be able to tell me what properties it has. And conversely, if I tell you that a quadrilateral has a certain set of properties, you should be able to classify it and tell me what type of quadrilateral it is. So let's try an example. Explain what the most specific name for this quadrilateral is. So as I was saying before in class, you want to start general and then work your way specific. So you want to start with the big circle. We're in quadrilaterals. Okay. Then you want to narrow it down. Well, is it a parallelogram? Is it a trapezoid? Is it a a kite? Well, in this case, we know we have a parallelogram. How do I know I have a parallelogram? Well, I see that the diagonals are bisected. Each diagonal splits the other in half. The diagonals bisect each other. Okay, so we're in the world of parallelograms, and now we want to see if we can get even more specific. Can I say that this is a rhombus? Can I say that this is a rectangle? Well, we know that there's a theorem that says because this is a parallelogram with congruent diagonals, you can see they're made up of the same size pieces, so the diagonals are congruent, then this is a rectangle. Okay, this is a rectangle because it's a parallelogram with congruent diagonals. And this is as specific as we can get. We can go through the other types of parallelograms. We can say, well, is there enough information to say that this is a rhombus? No. We don't know all the sides are equal. We don't know if the diagonals bisect the angles. We don't know if the diagonals are perpendicular. And because we can't say it's a rhombus, we can't say it's a square. So I say this is a rectangle, and then my reasoning is to the right. It's very important that you say that it's a parallelogram first, okay? Because there are two types of quadrilaterals with congruent diagonals. Rectangles and isosceles trapezoids. So it's really important that you say this is a parallelogram first, and then you conclude it's a rectangle. Okay, let's look at another example. What is the most specific name for the quadrilateral? Explain. Well, I'm not operating with a lot of information here. I have opposite sides are congruent, but only one pair of opposite sides. And I have this one diagonal that I know is bisected, but I don't know the other one's bisected. I'm going to try and add in a little information. See maybe if I can say something else. Well, I know vertical angles are congruent. And it would be nice if I could say that the triangles were congruent. But remember, you can't say that these triangles are congruent. Why? Well, this would be SSA. And we know that there is no SSA. Just think about spelling it backwards. Okay, so that doesn't help. We have another pair of vertical angles that are congruent here. But that doesn't really help either because we have those angles, but then we also know something about one other side. So I can't really say much about this. I've got a quadrilateral. I don't know anything about if sides are parallel. I don't know about consecutive congruent sides. So the best I can do here is that this is just some type of quadrilateral. And sometimes that is the most specific name you can give a quadrilateral. This is just a general quadrilateral. Take a look at another example. What is the most specific name for the quadrilateral? Explain. Okay. And we can only go based off of the information we have, okay? So in this case, the first thing I notice is I have a pair of parallel lines, okay? So that tells me that I'm either working with a trapezoid, and maybe I'm working with a parallelogram. And we'll have to do some investigating. Okay? So I'm given one pair of parallel lines, but is there enough information to tell me that I have a parallelogram, that the other pair are parallel? Well, automatically, there's not enough information to say that this is a parallelogram. Why is this not a parallelogram? Because the diagonals don't bisect each other. Okay? So it's not a parallelogram. This must be a trapezoid. Okay? Because we have one pair of parallel lines. Okay? So we explored our possibilities. We saw a pair of parallel lines. We know maybe we have a parallelogram, maybe a trapezoid. We justified why we have one and not the other. And then you need to say, well, can you get more specific? So I know I have a trapezoid, but it's possible for this to be an isosceles trapezoid. And we know this trapezoid will be isosceles if the diagonals are congruent. So 64 plus 80 is 144. 62 plus 75 is 137. So it's not an isosceles trapezoid. because the diagonals are not congruent. So the best we can do is that this is a trapezoid. Okay, so again, let's just go through that reasoning. We identified the parallel lines, so we know it's either a trapezoid or a parallelogram. We looked at the diagonals and saw that they did not bisect, so it can't be a parallelogram. Therefore, it's a trapezoid. One pair of parallel lines. Then we want to see, well, can we get more specific? Is it an isosceles trapezoid? So we check whether the diagonals are congruent, and they aren't, so it's not isosceles. Okay, a similar problem to this, and when I put this on my program that I use, the writing came out funny, so I had to retype it a little bit. A student knows the following about quadrilateral MNPQ. Segment MN is parallel to segment PQ. Okay, so I have M, N, P, Q. And the diagonals are congruent. Okay, so these are parallel, and MP is congruent to NQ. And he says, well, this must be an isosceles trapezoid. And the key word that we're taking issue with here is the word must. The only thing this could be an isosceles trapezoid. Well, no. And all you have to ask yourself is, what other quadrilateral has a pair of parallel sides and congruent diagonals? Well, rectangles and squares also have these properties. Okay, so it can't just be an isosceles trapezoid. It might be, but it might also be a rectangle, or it may even be a square. So it's very important that you recognize, just because you have some qualities in your quadrilateral doesn't necessarily mean that there's only one option. Sometimes there are multiple in this case. Okay? So rectangles and squares also have these properties. So he can't conclude that the only option is an isosceles trapezoid. Okay? So there's that. And finally, what I want to do is go through a little chart, a little checklist to study. And so we're going to fill out the chart with a check mark if the given quadrilateral always has the property. And we're going to use the color purple. So let's go through parallelograms. All sides are congruent. Actually, let's go through based off of the property. So which of these quadrilaterals has the property that all sides are congruent? Well, rhombuses and squares. Okay, we know that's not necessarily true for all parallelograms or all rectangles. Definitely not true for all kites and all trapezoids. Both pairs of opposite sides are congruent. Well, we know that's true for a parallelogram. Therefore, it must be true for all the other objects that live in the parallelogram family. So it must be true for rectangles, rhombuses, and squares. Both pairs of opposite sides are parallel. Well, again, that's the definition of parallelogram. And if it's true for a parallelogram, it has to be true for the other types of parallelograms. Exactly one pair of opposite sides are parallel. Well, we know that's not true for parallelograms, rectangles, rhombuses, squares, because for those objects, both pairs are parallel. So this is the definition of a trapezoid. All the angles are congruent. That's true in a rectangle, and therefore square, because a square is a special type of rectangle. Exactly one pair of opposite angles are congruent. The only thing that's true for is a kite. For parallelograms and all the objects within parallelograms, we know both pairs of opposite angles are congruent. And for trapezoids, we know that we've got no necessary congruences with the angles. Diagonals are perpendicular is true for rhombuses and therefore squares, and it's also true for kites. Diagonals are congruent is true for rectangles and therefore squares. It's also true for isosceles trapezoids, but we don't have that on here. I'll just put that in the box. Isosceles trapezoids, that's true for. And then the diagonals bisect each other. That's true for all parallelograms. Okay? So your homework for this section, I gave it to you on Wednesday, but check the website. Feel free to email me questions. I'll try my best to answer them. And we will go over all the homework on Wednesday when we return. And we will also have a quiz Wednesday, just a reminder, on 8.4 to 8.6. So it's about trapezoids and kites, rectangles, rhombuses, and squares, and then putting everything together. And Wednesday will be the 19th, I believe. If we spend too much time going over homework, we will not have the quiz. Okay, so do your best with the homework. Email me questions. You have a lot of time to go over this and correct and redo. So please use that time well. Okay, thank you so much and enjoy your snow day.